The period of a wave is the time it takes a full wavelength to pass through a point. Now, waves are a way of transferring energy without also transporting matter. In a transverse wave like this one, the matter will instead move up and down to follow this pattern as it moves along to the right. We then define wavelength to be the distance between two equivalent points on the wave, like these two peaks. Notice that across this distance, we have exactly one cycle of the repeating pattern of the wave. If we look at this first peak, then the period of the wave will be the time it takes to reach here, where the second peak currently is. In that time, we'll see this whole wavelength pass through this line. We'll watch this and time it like so. So it took the peak 2 seconds to pass this line, which means it takes 2 seconds for our point to travel a distance of one wavelength, meaning that the period is 2 seconds. But is this the only way you can measure period? Period will also be the time it takes a particle to complete one cycle of its motion in a wave. Let's look at our wave again, but this time we'll be looking at how this particle in the wave moves. As the wave pattern moves, it tells us that the particle must be moving like so to keep up with this pattern. So in one cycle of the wave, the particle moves down to the bottom of the pattern, then back up to where it started, like so. If we remove the wave and just watch this particle move, we can use the time it takes to complete this motion to measure the period. This time, though, we'll time 2 cycles instead of just 1. If the period is short, then it can be quite difficult to measure just one cycle accurately. So if we watch the particle go through this motion once, twice, and see it takes 3 seconds, we can say it completed 2 cycles in 3 seconds. So the time taken for one cycle is found by dividing 3 by 2, which means the period is 1.5 seconds. So that's how we can measure the period of a wave. But what exactly determines what this period will be? Well, period is determined by how long it takes to produce a single wavelength of a wave. Let's explain this with a simple example of creating a transverse wave on a spring. Here we flick our hand up and then down to transfer kinetic energy through the spring as a wave. If it takes us half a second to move our hand up and down like this, then we will produce a wave with a period of 0.5 seconds. This is because each wavelength in the wave is formed by one motion of our hand. So the period of a wave must be the same as the period of the oscillations of our hand. For your exam, you should have a clear understanding of what the period of a wave is and how to measure it. It's a very important property of the wave that you'll be learning a lot more about.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!